Hey everyone, here is a 3D scan of a hydrofoil connecting rod. It was captured with the Creality Sermoon X1 and sent in by one of our viewers for reverse engineering. I've never actually seen a photo of this connecting rod myself, but I believe it's used to link the front and the rear hydrofoil wings. This rod looks like it's probably made from a cast aluminum. I don't think it was milled from a solid piece. The design is very simple, which makes it a great example for demonstrating reverse engineering in FreeCAD. In this tutorial, we'll be using three solid modeling commands: Extrude, Revolve, and Loft. I'm using Cloud Compare to do the basic point cloud alignment, and then I fine-tune it further in FreeCAD. The PLY point cloud file is available for download in the description. In FreeCAD, make sure you are working in the Part Design environment. Then go to Import and select the PLY point cloud file you downloaded. Select the point cloud, switch it to a brighter color, and set the point size to 1. Next, I'll turn on the origin plane visibility. Select the XC plane, start a new sketch, and then switch on the section view. You can see the point cloud isn't sitting at the origin, so I'll draw a 3-point arc around the circle. Measure how far it's shifted along the X and Y axis and note those values down. After closing the sketch, I will right-click on the point cloud and choose Transform. In the Transforms menu, I will enter the offset values I noted earlier into the U and W boxes. U corresponds to X and W corresponds to Y. Now you can go ahead and delete the alignment sketch. Next, I will select the XY plane and start a new sketch. Using the polylines and 3-point arc tools, I will trace a closed loop sketch that we will revolve into a solid. When all the lines connect properly, the end node will turn orange. Remember, a closed loop sketch is required before you can run any solid command. Now I'm using the trim command to cut away the extra line. Then I will draw the final line along the axis to close the sketch loop. Click on the sketch, then use the Revolve command to create the first solid. Next, we will make the cutout at the tip of the connecting rod. Select the YZ plane, create a new sketch, turn on section view, and start tracing the cutting profile using lines and 3-point arcs. Make sure the sketch loop is fully closed. When all the nodes connect properly, they will turn orange. Close the sketch selected and run the pocket command. Switch to symmetrical mode. Then drag the arrow until the entire area is covered. On the XY plane, create a sketch and turn on section view. Draw a line along the Y-axis so the two circles we will add are aligned vertically. Set the hole diameter to 6 mm. Press the D key to add a dimension between the two holes and set it to 35 mm. Close the sketch selected and run the pocket command. Switch to symmetry mode, and for the cutting depth, choose through all. Select the XY plane, create a datum plane, and move it along the negative Z direction until it sits just above the holes. Create a new sketch on that datum plane. Use the external projection tool to project the edge of the hole for reference, then draw a 3-point arc over it. We will use the arc center to position the counterbore hole circle. Set the hole diameter to 10.5 mm. Delete all the projection lines, close the sketch, and run the pocket command to create the counterbore. Turn off the point cloud, then select the circular face and create a new sketch. Turn on section view, then draw a hexagon size to match the point cloud. Apply the horizontal constraint to one side of the hexagon. Since FreeCAD doesn't support point cloud cropping, you may need to turn off section view and adjust the hexagon size again. This part of the connecting rod isn't symmetrical, it's cast. Turn off the point cloud, select the circular face, then create a datum plane, move it along the z-axis until it reaches the point where the profile begins to turn. Select the datum plane, create a new sketch, and draw a hexagon that matches the size of the point cloud. Apply the horizontal constraint to one side of the hexagon. Close the sketch, then select the last two sketches we created and run the loft command. Select the hexagon face, create a datum plane, and move it along the z-axis until it reaches the tip of the connecting rod. Create a new sketch on the datum plane and draw a hexagon that matches the size of the point cloud. Turn on the visibility of the previous sketch profile, select it along with a new sketch, then run the loft command. Select the XY plane, create a datum plane, move it above the hexagon and start a new sketch. Create two circles along the y-axis. Close the sketch and use the pocket command to cut them through. Turn on the visibility of the previous sketch. We will use two of its circles as a reference. On the same datum plane, create a new sketch. Right-click, use external projection, then select the reference circles. Create two circles for the counterbore with an 8 mm diameter. Delete the reference sketch, then use the pocket command to cut them to the required depth. On the YZ plane, create a datum plane and move it above the cutting hole. Then repeat the same hole cutting process. Select two edges on the hexagon and apply a 2 mm fillet. Select the fillet feature in the model tree, then click a polar array. Set the polar array axis to base Y and enter 6 for the occurrences. Now the connecting rod model is complete. I will export it as a step file. Now I'm opening the step file in FreeCAD and everything loads perfectly. This model will be used for fluid dynamics simulation. Here's a basic tutorial on reverse engineering in FreeCAD. Thanks you guys for watching. I'll see you in the next video.